Welcome to all. This is the last but one question of this wedge friction. Again, I took from the Google. I told yesterday, I typed in Google wedge friction. I wanted to know what are the questions usually what are the popular questions. I saw the sketch, that's all, sufficient. I did not bother what weight they are given there. That is my problem, my decision. Okay, see, find the value of P. See here, one thing important, usually so far, your wedge was this way, horizontal moving, block was lifting up. Now reverse, see here, find the value of P for which block B is on the verge of moving to right side, see this side. For all contact surfaces, take angle of friction 12 degrees. Okay, now, see here, see you make a note here, this 150, see this weight is 600 Newton. Even this wedge, or they called B and A. Okay, now problem is not there. Now wedge block not required. Anyway, this is the block. Earlier all, it is to be lifted. Now, to be moved to right side. See, as you apply load here, what will happen? It will come this way. It will push this side, this one. How, common sense, if you put something here, see, it will move right side. So, what least P required? See, find the value of P for which it is on the verge of moving is limiting case. Okay. This 600 Newton weight, this weight they give 100. Usually exam what they will give is, they will tell weight of block A, or that is wedge, is neglected. If neglected, this weight is not there. Leave it. Okay, then this 150 Newton, see, make a note here, and 200 Newton are given in the question. That is somebody, see, maybe a person of weight around 150 Newton is not a person weight, it is 15 kgs. Someone saw it moving right. He is troubling now. He is pressing down deliberately so that to make difficult to move. And as it moves here, somebody is preventing from this side. Troublemakers. Anyway, this 150 and 200 is I have given just to show the question. That is, they can give. Usually, see, it will not be there. Usually, these two, see, when you want to move it to right side, nobody will apply this force. Who will apply the force? See, people will go away from that one. So, this is 200 Newton, given. Okay, given forces. Okay, now, question over. Only brief solution. But you solve systematically if, my usual statement, what? If you are serious and want to learn, etc., etc. From beginning I am telling. Okay, start. Now do one thing. I am making 2 in 1. In all the questions so far, what I have done? If you remember, first I put separate free body for both, with only direction of friction, etc. Then I started solving with the neat sketches later. This time, see, once again, first do one thing, separate sketches. See block A, down P. This will press this side, a normal reaction here, RA, 15 degree. Why? This is 75 degree means with the horizontal 15 degrees. Again, X, Y, Y here. Then RA here. Then this weight is going to come down. Therefore, friction is up. See? FF limit for A, suffix not required, equal to 0.2126 RA. Somebody will ask now, sir, how you got 0.2126? I told here some data here. If you are, see, everywhere they told angle of friction is 12 degrees. So you are happy. Everywhere mu is same. Suppose somebody will question, from where, sir, you got a 0.2126? I will tell nowhere. Leave the class. I will tell leave the class only. After so many, question number 87, told so many times, how I got a 0.2126 is not clear means I cannot do anything. See, it is difficult to teach. So somehow this number you have to get. This all your statement. We know that limiting frictional force equal to etc. etc. That all you are right. You are right. That RA with normal reaction, and then see here. Here. From here, one normal reaction this way. R on A from B. And when this is moving down, friction for this is up. See? FF limit for AB. Then be careful now. FF limit for AB equal to 0.2126 RAB. This is free body for A. free body for B. See, 150 down, also weight 600 down. Somebody is troubling by applying 200 this side. 200 this side. Okay, then see, RAB, normal reaction for this one for A from B, reverse is reaction or force acting on B from A. Then if friction is up here, it is down here. Or see here, if friction is up here, it is down. See, when it moves down here, see, or when it moves down, this block B, it will rub. Question number 75. Again I am telling. Then here, one normal reaction RB, suffix not required. It is moving right side, friction left side, 0.2126 RB. Okay, now this much over. Now very, very careful. Now this small you make a note. Now you do one thing. Now start solving. See, start solving. This much you make a note. Okay, then remember, first consider which block. See here. Our unknown is here. Which one? A. P is the unknown. You should start from block B. Therefore, very important. See, first consider block B, yes, block P. First consider B. Why I told you? Or see here, unknowns P, RA, RAB. Unknowns here, RB and RBA. That's all. So first, after all this one over, first consider B. And remember, I told you these two are equal. These two are equal. 1000 times told. Okay, consider B. Okay, put one thing. See, you draw a neat sketch of only this much. Neat sketch. Now enjoy. Sigma Fy0, sigma Fx0. See, plus I will start from RBA. See, where is it? FF limit here. Okay. Something rubbed out here. Okay, FF limit. See here. Minus 0.2126 RBA plus RB minus 600 minus 150 equal to 0. Equation number 1 will come here. See, in terms of RBA, I am giving a hint for you. That is minus 0.2126 RBA plus RB equal to 750. Equation number 1. Sigma Fx0. See here. Plus RBA minus 0.2126 RB minus 200 equal to 0, equation number 2. Then what you do? You get these two equations, solve 1 and 2, get the value of RBA and RB. Actually, I should not give this one. Simple, there is no resolution here. You solve this one, get the answer. Okay. See, what way I tell you to solve it. Once this is over, then you do one thing, then come here. Consider equilibrium of block A. Block A, see. Everything same. RBA right side means RBA left side. Now, this answer is known for you. See how much it is? That is 376.466. 376.466 Newton. You make a note. That is the value. Where is it? Okay, then also FF limit for AB equal to FF limit for BA. This is told thousands of times. RBA is known. Substitute that RAB. You get this answer. Calculate. How much? 0.2126 of 376.46 will come. I note down 80.037. I noted down. Equal to 80 point. I noted because to save the time. Equal to 80 point. I don't know why it's coming so close. Equal to 80.037 Newton. Okay. Now do one thing. Enjoy. See. Start. Sigma Fy0 minus P. I written here. But you should not see here. You should write independently and check the answer. Minus P. Then plus RA sin 15. This time I am not showing arrow mark here. Plus 0.2126 RA sin 75 plus 80.037 equal to 80.037 minus 100 equal to 0. Equation number double round 1. Why? Already 1 is there. Sigma Fx0. Here. plus RA cos 15 minus, see here this one, minus 0.2126 RA cos 75. This is explained hundreds of times earlier. I wrote cos, sin, cos, sin. This question you write. Okay, then minus 376.466 equal to 0. Now you already, equation 1, from if you see here, you will get the value of RA. Only one unknown. RA will come. Once you get RA, substitute in that 1. See here. Substitute in that double rounded 1. Substitute in that 1. Okay, 1. You will get the value of P 171.876 Newton. In case any calculation mistake is there, you correct it. I think most probably correct it. Okay, now, last question of wedge friction. That is question number 88. But remember, this also I took from Google. I saw Google only for a sketch. You can also do one thing. You go to Google, type wedge friction, you can see all the sketches there and check it. And not taken any numerical from there and not taken any symbol there and never bothered. They have shown all these forces. I never bothered there what they are showing. I will show what I feel is correct. See, actually, I'll let you know, even in Google, if you type what actually is bending moment, Google will tell you bending moment is the internal force. It will use the word, it is the internal force. Utter nonsense. I will prove it. Wait for some time. That is one thing many people mistake it. They are in the wrong version, illusion. Someone told, they believed. I will prove for each and everybody who tell bending moment, shear force, axial force, torsion are internal. I will make a U-turn there. I will prove them, not one example, series of examples. Then finally I will ask them in the class, is it internal? No. They will tell no. Then external. But you tell internal, oh, everybody, we are all sorry. We are carried away by somebody told that way, we believed. So now remember, now onwards, if someone tells internal, you tell no, it is external. My name you tell them. I will prove it. You tell them, go and see this class. You will come, after finishing, you will come to your, he will come to your side. Yes, correct. So therefore, Google, I see only for sketches. Even so many, when I go for other chapter also, sometimes, because Google, what happens is, they give plenty of sketches there. And examples, I see the question there, this way. Numericals, I will not bother. How they solve, I will not bother. But of course, sometime I'll check whether they are solved correctly or not. Okay, I got capacity to check it. Okay, now, question number 88, last question. Interesting question, over. Very easy question also. I will write and solve. Last question of wedge friction, 88, again taken from Google. I saw this arrangement. See, this is somewhat an interesting question. Don't ask me, sir, how this is possible, what is going on? See, in engineering mechanics, in so many questions, what is going on, you should not think. See, even wedge friction. See, this block, why it should be always like this? It may be horizontal also. Then this should be what? If it is horizontal, this should be inclined. Some arrangements are required. So that all you don't bother. In engineering mechanics, you don't too much worry about what actually is the structure. Arrangement of forces or arrangement of the different parts are important, given in the question. Okay. See, a weight A here, this is called, instead of wasting time, this is called a block, this is called a wedge. See, there is no wedge. Actually, these are wedges. This is block. See, this weight is 6 kilonewton. I am naming A. These two are of weight 800. Usually, remember, they can give these two weightless, or they can tell weight of B and C, or are ignored, or they may give only this weight. Understood that they are very lightweight, ignore it. That is, don't consider 800 Newton later. It does not affect. Okay, now, see, what they want, they are applying either side P. See, as you apply P here, tell what happens. Common sense. Surely this block will slowly get lifted up. Why means you have some arrangement. You see, you can't apply both P this way. No. If you apply the P this way, these two will move inwards. See, these two will move inwards. So as a result of this one, this will get lifted. So find the value of P for which A is on the verge of getting lifted is the question. Now be careful. See, this angle is 65 degrees, given a 65 degree. See, this contact surface mu 0.3, these two contact surface mu 0.25, or what they can give usually. In the question they can give, take mu equal to 0.2 everywhere. Okay. Now, see, one weight given in kilonewton, other two weights given in Newton. So you should decide now, are you solving in kilonewton or Newton? Anything will do. Better kilonewton. Okay. If you solve in kilonewton, see, this is 6 kilonewton. Later, these two are 0.8 kilonewtons. You should not write 800 Newton. 0.8 kilonewton. Or, if you are solving in Newton, later for these two, you write 800 Newton. This you write 6000 Newton. That is common sense required. Okay, over. Now, first consider free body and also equilibrium. See, actually, you consider free body and then consider equilibrium. This is standard statement. You write consider free body also will do, consider equilibrium also do, because when you consider equilibrium, you have to always consider free body. Understood? Okay, start. 6 kilonewton acting down. See here. There is one contact surface here, a normal reaction here, RAB, reaction for A. See, this is your A. This is your A. Reaction for A from B, this way. And here also, see, one normal reaction. Normal reaction. Reaction for A from C, RAC. If this is 65 degrees, see, this inclined line, this plane makes 25 degrees with horizontal. If this is 25 degrees, these two are 65 degrees. This is primary school mathematics. Okay, now, then friction, see, very important. These two will rub this one this way. See, this way it will rub. Therefore, later, see, for this one, this will rub this way, this will rub this way. See, upper block, you have to always consider rubbing force. Or, if you go to other method, see, relative motion, see here. If this goes, see, if this goes right side, it will look like going to left side. So, friction right side. Now, if this goes, see, this goes left side, this will look like going right side. So, friction this way. Or, friction for the upper block is always in the same direction as that is, its force, if you resolve, should be same as P. This also I told, example number 75, once again. So, first of all, I am wasting time explaining these two. See, RAC, RAB, FF limit 0.3 RAB. RAC, FF limit 0.3 RAC. Okay, start. Sigma Fy 0. Now I nothing to be done. I won't show, okay, this question I will show it if you want. See, only one question. Cos sine. Cos sine. Cos sine with respect to 65. Cos sine 25. Cos sine, I won't, okay, right, sine cos. Sine cos. Sine cos. With respect to 65. Again, here, see, for this one, we have to write here. Cos sine with respect to 25. Okay. Start. Plus RAB sine 65 minus 0.3 RAB sine 25 plus RAC sine 65 minus 0.3 RAC cos, how much? Sine 25 minus 6 equal to 0, equation number 1. Sigma Fx 0, right side positive, plus 0.3, here, plus RAB cos 25, plus 0.3 RAB cos 25, See, then minus RAC cos 65 minus 0.3 RAC cos 25 equal to 0. Equation number 2. Solve 1 and 2. You get RAB and RAC. See there, both came equal. Okay, now this is right here. This is systematic solving. Now make a note here. See, make a note here. Actually, we can solve much easier way. See, much easier. Use symmetry. See, use symmetry. This is a perfect symmetrical. See here, symmetry means, remember, see, vertical symmetry. See, horizontal, see, vertical symmetry means both should be vertical. Horizontal symmetry means this way, not this way. See, this is vertical symmetry. Horizontal symmetry is not this way. See, this way or this way. Therefore, perfectly symmetrical here. See, right here, due to symmetry, you can write here, due to symmetry, perfect symmetry, you can directly write what? You go that side. See, you don't consider RAC. Whatever RAC equal to RAB. See, whatever is this reaction equal to this reaction. Then, see, then you need not write sigma Fy, sigma Fx both. Directly, see, sigma Fy0 take upward positive. See here, plus RAB sin 65, RAB sin 65. Then, see, this also same way. Wait a minute. Then, here, minus 0.3 RAB sin 25, 0.3 RAB, I am not using red color, okay, I use red color, RAB. That is same equation, RAB sin 65 minus 0.3 RAB, how much? Sin 25, sin 25, actually that equation only, see, then plus RAC, once again, sin 65, minus, see this one, here, minus 0.3 RAC, minus 0.3 RAC, sin 25, minus 6 equal to 0, then do one thing, replace what? Replace RAC, replace RAC by RAB. Why? Because of symmetry, I told. Because of symmetry, RAC. So, RAC change over to what? See, RAC again change over to RAB. This also change over to RAB. So, only one unknown. Therefore, you will get the value of RAB. You will get the value of RAB. I will check the camera once. Okay, no problem. If I check this one, someone will comment, this person tells so much about concept and he does not believe it. No, I will not calculate. Plus 3.8485 kilonewton equal to your RAC. Oh, see what answer you got here? Same answer you will get here also. Sigma Fx is not required. See, in case you make sigma Fx 0, see, you can see here, RAB cos 65 minus, this will cancel. This will cancel, 0 equal to 0 will come because symmetry if you are using. So, advantage for you, okay, your choice. So, now you got RAB and that's one. Okay, now, I will remove everything now. Now, I will consider free body. See, remember now, make a note. This reaction came equal this reaction and this reaction equal this friction equal this friction. Now, you can consider free body of either B or C. Both are not required. Any one of them will do. You make a note here now. See, this I will remove. This I remove now. Okay, this all not required now. Okay. I want to bring this more space here. Okay. More space here. Okay, now right. Now make a note. Once you get this answer, now consider free body and equilibrium of either B or C. Any one will do. Because why? Because here also P, here also P. Okay. We will consider B. We will consider B. Okay. If you consider B, see here. I have not written here. I will show it now. See. Little bigger. Okay. See. Further bigger. Okay. Space is there. I can mark clearly everything. This way. Okay. Now see. This is the contact surface. This is your B. This weight is given how much? 0.8 kilonewton. Because you are solving in kilonewton. Then see, this line with horizontal makes 25 degrees. You know it. Now see here. Up RAB. Perpendicular to plane. This way RBA equal to RAB. Equal to known value now. How much it is? Equal to 3.8485. 3.8485 kilonewton. Okay. Then this way 0.3 RAB means, see, it is this way here. This way 0.3, this way 0.3 RBA equal to 0.3 RAB equal to, get the answer, 0.3 into RAB, calculate. 0.3, okay, calculator is not on, okay. 0.3 into 3.8485. 1.1546. 1.1546 kilonewton, 1 minute. Because sometimes I am coming too close to right side. If required, I will tilt the camera slightly. No, the space is there. Okay, now I got more space. I have put the recording on. Yes. Suddenly got doubt whether recording is on or not. If recording is not on, my complete effort is wasted. Once again I have to record. Okay, now see here. See, later, this angle how much? See, with horizontal, this will make 65 degrees. So later, cos sine, you know it, here, later, cos sine with respect to 25 degrees, here. This contact surface, just a reaction, normal, is moving which side? This side, okay. A normal reaction of RB, no suffix required, and this is moving right side. So since I am doing this block, friction is left side. That is, this coefficient is 0.25 RB. 0.25 times RB. Okay, over. Free body over. You can take either free body of B or free body of C. Both are same. I will remove this one now and solve the question. Lastly, over. Okay, here I write. Don't see other things. Other things all don't see it now. Okay, now, start. Sigma Fy0, take upward positive, plus RB. Oh, sorry, I forgot to write P only here, see. Otherwise, question is P, okay. Otherwise, anyway, I can make out later, because if I don't put P, then what I am finding, see, plus RB, I can make out. Plus RB, that's all. Minus 8, minus 3.8485 sine 65, again plus here, plus 1.1546 sine 25 equal to 0, you will get the value of RB. P will not come, it will come in kilonewton. Let me calculate, okay. Okay, 1 minute, lastly. Then, sigma Fx0, take right side positive. You write plus P, see, plus P minus 0.25 RB, minus 0.25 RB, this RB, then minus 3.8485 times cos 65, again minus 1.1546 cos 25 equal to 0. What you do? Substitute for RB. See, just now you got RB here. Substitute for RB, you get the value of P. Someone will ask, sir, why you are not substituting? I will tell, who is learning? Sir, we are learning. Then you want me to do that also? You cannot substitute and get the answer? Yes, sir, we can do it. Then why you asked it? Sorry. Then they will tell, sorry. Okay. It is 8 plus 3.8485 into sin 65 minus 1.1546 into sin 25. 11.4739 plus 11.4739 kilonewton. Substitute here. If by chance my calculator has got a problem, if it is wrong, correct the value. What is there? Don't make issue of that one. You will learn the principle. So it is 0.25 into 11.4739, then plus 3.8485 into cos 65 equal to plus 1.1546 into cos 25. P will come plus 5.5413 is the answer as per calculation done by me in this old and problematic calculator. Remember that way. Sometime one number will not come. In complete subject I will tell. Such thing, if anything is wrong, you correct it. But strength of materials and structure analysis, maximum times that will not happen, because the moment I get the answer, I will do something like this and get the answer. I can check the answer. Majority of problems, I can check the answer. So since I can check the answer, majority questions, I can make out immediately. Here, who will check it? If wrong, correct it. Okay, now that's all. 88. Next class, question 89, we are starting the last part of the friction, that is ladder friction. See, for mechanical people, there is one more friction called screw friction and belt friction. That I am not covering. Because why? That screw friction, belt friction all, I am not bothered because it is not required for me. For civil students, when I teach, if it is a mechanical students are attending the class, I will tell them, you refer and do it. Some formulas are there with respect to mechanical part, not required. See, even though I am telling complete coverage, some of the parts I will not cover here. Because why? It is mainly based on basic. Anyway, those who want can study it. Once this much knowledge you get, you can always study what is there. Okay. Next class we will meet. Thank you. Welcome back to the same class. See, when some guest will come, you first tell him, welcome, come, sit. Second time you don't tell. What happened is, the guest came, you told him welcome, you forgot it. So once again, welcome. I will tell what is the problem. After recording is over, I just stood here and looked at the question. I checked the reaction, RB, 11.4739. Impossible. I know something is wrong here. See, no technical mistake. What is wrong? What is wrong? What is wrong? I was wondering. I didn't see. I checked everything. Suddenly realized, oh, this is, see, it is not 8, it is 0.8. See, what is this? See, severe mistake. See, so make a note here. It is not 8, it is minus 0.8. 0.8. Okay, now I will tell you how I came to know. That is using principle. Okay, so it is 0.8 plus 3.8485 into sine 65 minus 1.1546 into sine 25. It is coming something wrong on this. 0.8 plus 3.8485 into sine 65 minus, see, I have not closed the bracket, minus 1.1546 into sine 25. It is giving 3.79997. See, in the calculator giving 3.79997. That means I can take it as how much? 3.8 kilonewton. 3.8 kilonewton. So, therefore, RB is not, that is a wrong answer. Your RB is how much? 3.8 kilonewton. Your P will change. I will tell you how I got it. 1 minute. So, minus 0.25 into 3.8 equal to how much? Y minus, plus I can take 0.25 into 3.8 plus 3.8485 into cos 65 equal to plus 1.1546 into cos 25. It is coming 3.623 kilonewton. Okay, I'll check once again, because when I correct it here, 0.25 into 3.8 plus 3.8485 into cos 65. What is wrong here? 0.25 into 3.8, then plus 3.8485 into cos 65, then again plus 1.1546 into cos 25, 3.623. Okay, change the answer. That's why in the title I have written there, C correction at the end, in the bracket, C correction at the end. Okay, now, description I won't write because so many will not see description. Title they will see. Now, I will tell you how I came to know. See, this is where your structural knowledge will count. When I was observing here, weight is 6 kilonewton. You got around, how much answer you got? I forgot it now. High value you got. When I looked there, I felt that much weight is, force is not required. To the inner mind, it came to me, that much force not required to lift it. If this weight is 6 kilonewton, half is 3, little more than 3. Because of the friction, etc. here, so see, friction coefficient is not very high. To the inner mind, I got the answer. See, 3 kilonewton, say something like some 20% more, or 20, not 20%, 10-15% more of 3. 3 is 15-20% more. 20% means 20 into 2 into 0.3, I don't know, 20-25%, around 0.6, 0.7 more. So I was expecting, see, weight 6 means each will get 3 kilonewton. So I thought 3.5, 3.6, 3.7 in that range. But we got high value. Then I looked there, whatever I checked, still it is giving wrong answer. Because then I closely observed. I observed one thing. See here, this is out of syllabus for you. This weight is 6 kilonewton total. 6 kilonewton. See, this weight is 0.8. This weight also is 0.8. So, if you consider the complete equilibrium here, 6 plus 0.8 plus 0.8, the total vertical load here is 6 plus 0.8 plus 0.8 is 0.8 plus 0.8 is 1.6. 6 plus 1.8 is 7.8 kilonewton is the total load. See, it is symmetrical here. Since the total load is 7.8 kilonewton, for equilibrium, this reaction and this reaction each should be 7.8 divided by 2 equal to 3 point, how much it is? 7.8 or 7.6 actually. See, 0.8 plus 0.8 is 1.6. 1.6 plus 6 is how much? 7.6. 7.6 divided by 2 is each reaction should be 3.8 kilonewton. Then I saw there the reaction came higher. Then suddenly I realized, yes, see, mistake is, it is not 8. I did not see that point. It is 0.8. Now see here, 3.8 kilonewton. I know the answer. By looking at the arrangement only I know it. See, if you apply a load this way to 6, 0.8 plus 0.8, total 7.6, two horizontal supports. See, no reaction will come this way. See, there is no contact here. So therefore, for equilibrium, this, if total load is 7.6, each will get downward load of 3.8 kilonewton. Correct, see, 3.8 kilonewton. See, this is where your structural knowledge counts. Anyway, by chance, if I have not observed, if I rub the board and went, it is not technical mistake. It is a print mistake. But somebody would have commented, this person should know at least that symmetry is there, 6, 0.8, 0.8, 7.6. So this should have come, how much? He should have got this reaction. See, this reaction, he should have got half of that one. But he got some other answer. He did not observe because at that time, I was not observing all this. Some answer came, I wrote it. Procedure important. But see, now nobody will comment. See, when I looked there, it has, see, that force answer came, it gave me uneasy feeling. Somehow I felt, no, that much force is not required. See, this is where in structural design also is countful. When you do structural design, suppose you do RCC, when the reinforcement comes, or when you design, when you get shear force and bending moment, if you have a good solid knowledge, suddenly you will tell something wrong. Something wrong. See, that feeling will come. That's why even if you do use software, basic knowledge is required. Okay, now, once again, thank you. We'll meet next class.